Sweet. Okay. All right. So let me start by sharing my screen and showing you what the bucket class API looks like, and what we want to bring in. Um, let's see. Okay. Here. So last week when we were talking, the last thing where we left off was about taking this protocol field out of the bucket class and putting it into the bucket request. The reason for this was protocol specific parameters are really things that the user would want to specify and should be able to specify. For instance, a user that's requesting a bucket should be able to say that the bucket is present in a particular region. Now, by putting it in the bucket class the way we do it today, we are forcing an admin step in the middle for something like this protocol, um, and also we're forcing an admin to create. If they wanted to avoid this manual step by the admin, then the admin would have to upfront go and create basically every possibility of or every combination of protocol parameters possible, and have the users choose one of them as needed. I think it just makes more sense to have protocol be a part of the bucket request field, because that also cleans up this user experience of how a user would request a bucket with certain parameters.
Um, so Sid, historically, protocol was in the BR and the BC, and we had a list in the BC, and if the br.protocol was in the BC's list, then it was okay, and if it wasn't, there was there was an error. We retried. Um, One of the reasons we moved it out of the BR was this idea that it shouldn't matter. Now, I don't know how sound that idea is, but the idea being, they just want a bucket and they don't care that much.
Mm-hmm.
Um, and so put as much in the BC as we can and make the BR simple. That was the
Mm-hmm.
philosophy. I'm not
Mm-hmm.
trying to defend that philosophy, but I think that was the philosophy similar to PVC, where
Mm-hmm.
they don't care that much, but then over time it turns out they actually do care, and we have
Mm-hmm.
modes and volume modes, and maybe it does make sense for protocol to be in the BR.
Mm-hmm.
Um, but if it's in the BR and not in the BC, then
Mm-hmm.
you have a potential mismatch between driver and protocol, right?
Well, um, this is something that Ben brought up as well last week. So, um, if you don't have a driver that can satisfy this protocol, or if your driver cannot, your bucket request is just in a limbo. It just doesn't get provisioned.
But we know that late in the game. I mean, in terms of reporting that error so the
Mm-hmm.
user sees it,
Mm-hmm.
they don't know that error until they
Later
don't
on.
get it at the time they create their BR, for
Mm-hmm.
instance. Um,
Yeah, that's pretty consistent
well,
with
maybe
how.
they could. Well, we don't know. I mean, we don't know. Cozy doesn't know what protocols a driver supports, right?
Right, and it can support multiple even sometimes.
So, so we can't report that error until the driver is called to create a bucket, and then the
Correct.
driver says, "Hey, I don't know that protocol," and then we report an error.
Correct. Correct. It's no different from them choosing a driver that doesn't exist.
Agree about that.
Yeah. So, like historically, how if you look at
Hey, can you
story.
guys hear me?
Yeah.
Sorry, I was on double mute. I'm talking to myself. I was going to say that there is a difference if the driver doesn't exist, because as long as the driver exists and the sidecar will see the request, a sidecar will try the operation and it will fail, and then you'll post an event to the BR saying like, "Hey, I tried to provision this and it didn't work, and here's why." Right?
Mm-hmm.
Events are nice mechanisms for human readable feedback in that way.
Mm-hmm.
Um, if there's no driver at all, there's nothing in the system. It just sits there, right? Like there's no controller whose job it is to go find PVCs, mapped storage classes that have no provisioner associated with them. Presumably the same will be true with buckets. If you pick a bucket class with a driver that literally doesn't exist, it's nobody's job to tell you that that's what you did. It's just nothing happens. You
So
sit there.
if you look at, yeah, that's true. That's absolutely true.
But
So
why would we allow the creation of a bucket class if there is no driver behind? That's a
not
bit
a bucket class. I mean, we won't disallow it because the idea is the driver might come up later.
okay.
So
Yeah,
that's the
the
reason.
thing about Kubernetes is you have all these out of order operations where you have late binding of things. So you can install the storage class first, the driver second, and the PVC third, or you can create the PVC first and the storage class second, and or you can do it in any order you want. As long as they're all three eventually get there, you'll get an output that works.
Okay.
Yeah, that's right. So talking about the events, if you look at the events from volume binding or dynamic volume provisioning, the first thing it says is waiting for provisioner to create volume, and if no provisioner is found, it just throws an event after it doesn't even have to throw an event because it just gets stuck at waiting for provisioner, which someone could read, and it's not hard to imply that they couldn't find the provisioner. So if we were to word our event from our controller saying that waiting for bucket provisioner to provision a bucket or create a bucket, and then there's no more events because there's no provisioner for whatever driver they've chosen, then that implies that the provisioner by that name doesn't exist.
Yeah. I mean, I think we can follow the volume model, the PVC model here, and we'll be fine. But to get to Jeff's specific question, like, yeah, if you do get the driver name right and there is a driver, but you just get the protocol wrong, then the sidecar will see the request, send a RPC down. It'll get rejected by, like, say, I don't know how to speak that protocol, and then an event will get posted saying, like, you asked for a protocol that the driver doesn't support, and then you'll know why your bucket request didn't bind. So as long as there is a driver, there is something that will fail and post another event, giving you a better clue what you did wrong.
Right.
Another way of asking it, Sid, is if protocol is in the BC, how is it, and the BR declares the BC, this is the BC I want. Why isn't that the same as saying this is the protocol I want? Everything, the details are in the BC, but I have said which BC I want when I create my BR.
Because the user cannot.
Jeff, were you not here last Thursday when we went through this long debate? Because I started exactly where what you're saying now, and the way that they convinced me is they said it's a portability issue, right? If I just pick up my workload from one cluster, move it to another cluster, and for example, I'm not even using a bucket class, I'm just accepting the default bucket class. Who knows what I'm going to get? And it matters because the workload is coded to a specific protocol, and the protocol is tantamount to, like, the volume mode in the PVC world, and the volume mode is a parameter of the PVC, not the storage class, because it's intimately tied to how it will be used by the workload. And so it makes more sense to have it be on the workload specified object for portability reasons, so that I can pick up my BR from one cluster to another cluster and drop it there. And what will happen is either everything will work well, or I will get an error, but you won't have a situation where, like, I get a bucket and it's the wrong kind of bucket, right? If we put it on the storage class, there's this possibility that the bucket does get provisioned and the workload can't use it because it's the wrong protocol.
My argument to that would be that part of portability requires that the admin created resources are identical on the new cluster, and that would include
User created resources are identical. Admin created resources can change.
I couldn't hear Sid.
Yeah.
I couldn't hear what you said.
Go ahead, Sid.
Oh, I was saying the expectation is that the user created resources are identical.
Yes, but the admin creates the foundation. Storage classes and bucket classes are the foundation for the user workload. If those are different, you can't expect, you have to be accepting that some workloads won't work then. If you change the storage class, you change provisions.
So in the
even
limit,
for defaults, that would apply to a default as well.
In the absolute limit, it's true that, you can't guarantee that every single workload that worked on cluster A will also work on cluster B if the configuration is a little different. But you can, the way Kubernetes is set up with storage classes and PVCs, the vast majority of PVCs that work on one cluster will work on another cluster, because what a PVC is asking for is a file system. And you know, yeah, it could be that certain workloads depend on like some very specific XFS parameter that's present on one cluster that's not present on another cluster because it doesn't set up to use XFS or whatever. I mean, there's always these tiny little details that can go wrong, but like as long as you don't do anything unusual, as long as all you were expecting was a generic file system and that's all you're going to use it, you can be pretty sure that no matter what cluster you land on, you pick the default storage class, you ask for a volume, it's going to give you what you need. With the
Yes, but what if the
exception to that,
provisioner is different? What
Huh?
if you said, if you're to exaggerate some, I am exaggerating intentionally. If provisioner names are different on cluster B than cluster A, you don't have that guarantee. And
no, you do. Like so I could have like a workload that's running in GKE. So it's got the Google GCEPD CSI driver cranking out my PVCs, you know, and I leave my storage class name blank and accept the default, and I get GCEPD volumes. But then I pick up that workload and I move it over to Azure, and then I don't actually know what Azure calls their volume driver, but whatever their volume driver is, it will create PVs that match my PVC, and it'll be a totally different implementation under the covers, but it's going to look the same to my pod. It's going to be a file system of a size that is at least as big as what I asked for. And like,
yeah,
as long as that's all I needed, it's fine. And it would be really, really hard to imagine a Kubernetes cluster that couldn't give you a file system of a size, which is basically all the PVC lets you ask for is I need some persistent storage and here's the size I need. And you can set some modes or some access modes and various things. But basically it's very generic so that, you can
get portability because you have POSIX underneath, essentially, for file.
Yes.
Or iSCSI standing for block. And that gives you.
But like you would never see the iSCSI, like whether iSCSI is there or not is invisible to your workload because it's been wrapped up inside the CSI driver, and there's a file system on top of it, and the kernel's mounting it, and the underneath bits are invisible.
Right, but you have data standards for file and block, and we don't have that for object.
But what we have is the protocol. So
Yep.
So the whole thing was, as long as all you want is a file system PVC, you can really go anywhere and it will just work. The exception is with the volume mode. We added volume mode in Kubernetes, I don't know, 10 releases back or something. So you could actually request a block volume. Block volumes are fundamentally different than file system volumes because it's just an array of blocks rather than a POSIX style file system. And so if you go to a Kubernetes cluster that only knows how to give file system PVCs and you ask for a block volume, it will fail in the mode where you just sits there and nothing happens, right? Or you get your PVC gets an error, but it doesn't bind.
And so workload doesn't ask for the block volume. The storage class does, right?
No. The volume mode is a parameter of the PVC because of this reason.
In the PVC, right?
Yeah, but because it is so intimately tied to the nature of the workload. A workload that's expecting a file system cannot accept a block volume, and a workload that's expecting a block volume cannot accept a file system volumes. It's fundamental to the workload, so it's part of the PVC. And what we're arguing is that the object protocol is of a kind with volume mode that it is fundamentally tied to the workload. If workload is expecting an S3 bucket and you give it a GCS bucket, like you're done, right? You're not going anywhere.
So what you're saying essentially is volume mode is like protocol.
Yes.
PVC is like the BR, and Kubernetes learned that they actually had to put volume mode in the PVC to support the big difference between block and file. And all you guys are saying is that same logic applies to protocol, right?
Mm-hmm.
Yes.
All right, I'm done.
I think we need to check with Sad because I remember we actually talked about this before because I was wondering why the protocol is in the bucket class, and then there was some discussion. I forgot what Sad said. This was quite a while back when John was still here.
So I think you're saying something along the lines of that's how we do it with storage classes. I thought about it a little bit more, and actually with storage classes, with storage classes, it's a little different. The argument earlier was something like um, in the PVC we specify very little, and the configurable parameters all went into storage classes. But again, just like Ben was explaining, it's more contextual than that, where stuff like volume mode, which the protocol is the equivalent of, would go into the PVC rather than into the storage class. Similarly, stuff like protocol, which is more intimately tied with the bucket itself, and less so with the a generic class, would go into the bucket request. Another point that was made was something like you want to have fields in the class objects, like the bucket class and storage class, that are more or that are I would say that relate to how Kubernetes orchestrates buckets, and less to do with the actual bucket itself. So stuff like allowed namespaces or deletion policy, which is a Kubernetes specific concept around orchestrating buckets, would go into the class, whereas things like protocol or anything else that's specific to the bucket itself and not specific to Kubernetes would remain in a bucket request, which is ideally where you want to specify it. And that's kind of the boundary that storage class also defines. Does that make sense?
Yeah, it makes sense. But I think we should check with him, because last time I just don't remember exactly what his argument was last time.
Okay. Yeah, it would be good if he joins the meeting. It'll be good if he can move fast. I will reach out to him today. Hopefully by Thursday he's able to respond.
Yeah,
Or
sounds good.
this week. That should be fine, right?
Yeah, it's fine. I actually think it makes sense to move this out. I mean, I didn't know why this was here, because I remember I actually asked this question one time back. So, but
Right.
maybe check with him and,
Yeah.
and see.
Well, I think part of the original logic was we were thinking, wouldn't it be nice if you can use bucket classes as a way to advertise to the users the menu of available choices, including the available options for protocol. But yeah, as we discussed, I guess it was last Thursday, that you really needed to also be on the bucket request for portability. And if you put it on both, then you start to get really weird issues with, like, what is your source of truth, right? Because you get to specify which bucket class you want too. And if the protocol on your BR doesn't match the protocol on your BC, then what does it even mean? So we decided, yeah, it should really just be on the BR. And if you guess wrong what the protocol is allowed, you'll get an error back that says you asked for a GCS bucket and we don't do GCS here, and sorry, or at least this bucket class doesn't do GCS, so go pick another one. And then it's up to the admin to communicate out of band, which bucket classes can do which protocols.
Right. Okay.
But the same problem exists today with storage classes and raw block volumes, right? Today, if you want a raw block volume and the storage class doesn't support it, you just have to figure out which one does, right? The system doesn't help you. So it's no worse than the existing status quo.
Right. The error messaging. Okay, so yeah, we can't tell it up front, and I think that's okay. Like everyone, like Ben was just mentioning. Okay, now I want to get into allowed namespaces.
Oh yes, the can of worms.
Yeah. So allowed namespaces. Really, the idea behind this is we should restrict buckets to only certain people that should have access to the buckets. I was trying to understand this better, because the way we've done it today is we have a static list of strings which are supposed to signify each of the namespaces that that are allowed to access this bucket. I think.
Hold on, let's go back to the beginning with this. So in the greenfield scenario, this is totally irrelevant, right? Because you ask for a bucket by creating a BR in a namespace, and it's going to get bound.
I think going that way we're confusing ourselves. I think I want to redefine the problem a little bit, and go a little bit Yeah. So if you think about volumes, just like block device or file systems, let's take EBS volumes for instance. There's a natural boundary to those volumes. Those volumes cannot move past availability zones. They're stuck to it, and so we have the concept of topology there. Um, and topology, restricts who gets access to the block device, based on the technical limitations of where the volume can be attached or mounted. Now, in case of buckets, since it's always over the network, that technical limit doesn't exist.
Well, I was going to say, I don't think that what you just said is true about topologies. Like topologies are an optional feature that can help you ensure that things get provisioned closer together. And it can, if there's underlying limitations on what can connect to what, it can avoid getting into the situation where you put the pod in the place where the connection is going to fail. But it doesn't by itself prevent you from
Right.
trying to do something. It just tries to steer you. It's like a guardrail so that you don't go over the cliff.
The topology can be advertised by the driver.
Yeah, but it's
So
optional, right? And
right. So the expectation is the driver knows. Say the AWS EBS driver would know that this is the availability zone it's in, and then whenever the controller creates a new volume, it could create it with you know required topology and preferred topology, saying these are the places it can possibly go into. It can restrict in that sense.
well, it can tell the driver to restrict its choices, but
No, the
if
driver can specify these are the only kinds of nodes where I can run.
well, right, it can go both ways, right? You can, when you create the volume, you can specify a topology saying like, don't put it anywhere other than this place. And that's where, because if you already know where the pod is going to go and you want the volume to end up close there, you can sort of steer it that way. And you can do the opposite too. You can say, you know what, put it somewhere and then tell me where you put it, and
Yeah,
I'll try to
that's
put the
wait for
pod
first
close to that.
consumer. Yeah, that's
Right,
wait for.
but
I'm
but
talking about
it's
something different. Go ahead.
but it's not a secure. I want to emphasize, it's not a
Yeah, it's not a
security
security
mechanism.
policy. I agree. I agree.
Okay.
The reason I even brought it up is because buckets don't have such technical limitations. I'm now wondering why even have this concept of allowed namespaces here. What if
It
we?
was for security, for the brownfield case, right? That was the whole reason. Is in the greenfield scenario, you don't need this field because you create your bucket request in the namespace, and then it naturally gets bound to a bucket. And as long as other users can't access your namespace, your bucket's protected, and other people can't just get a hold of it. But then when we started going down into the, like, how do you share a bucket across multiple namespaces, or how do you even get multiple copies of a bucket, or if you didn't create it at all from Cozy and it's a pre-existing bucket and now you're trying to import it into Kubernetes, how do you prevent everyone in the cluster from just latching onto the bucket? You need some sort of control, and I thought that was the purpose, is
right.
If you didn't want everyone in the cluster to have access to the bucket, this is your lever.
Right. So
And
what I'm
doesn't
trying to
it,
say is namespace is the wrong boundary. It's really not namespace you're looking to control access over. It's really users or groups. And we looked into RBAC and we said RBAC cannot restrict access to particular resources. And by default, RBAC cannot, but that statement is not true. The previous statement is not true that RBAC cannot restrict access to particular resources. So what we need is a admission controller or authentication. I don't know what it's called. Admission controller. Um, Admission controllers do get information about stuff like who's the user or who's the group that is actually requesting for a particular resource type. And admission controller can clearly can reject or accept a request based on the user, the group, or any other parameter that it wants to use. So in reality, RBAC over particular resources are possible. You just need to implement it yourself.
I'd like to
Okay.
go back to something Ben said.
So, yeah, 1 second. So, does that make sense? The fact, the whole reason we went into allowed namespaces was because we thought RBAC wasn't possible. Now that I know RBAC is possible, and I can show you,
I
on
mean,
particular reason.
I buy your argument that, yeah, you can do RBAC by resource name. I would want to see that spelled out into a whole brownfield bucket import scenario. Like what are the steps where you grant the access to the thing you just created? Because if you're going around modifying cluster roles or roles all the time, every time you import one of these things, that feels weird to me. But go ahead. I
Yeah,
think Nicholas was going to say something.
yeah, go ahead, Nicholas.
Yeah, you only mentioned the brownfield case. Now, I'm not sure the allowed namespaces or some equivalent could be RBAC based. Only applies to brownfield. It also applies, I believe, to greenfield, insofar that one could have a provisioner,
Yeah.
a driver for Cozy, which can create buckets in multiple tenants, which is somewhat unlike Sid's earlier example of creating an EBS volume, which is like your cluster runs in AWS account X, so the EBS volume is created in X, whatever. If you have a Kubernetes, the object storage system sits outside of your Kubernetes cluster, so you could have a driver which can, for one bucket class, create a bucket in account/tenant A, and for another bucket class, create a bucket for account/tenant B, which are completely distinct, in which case you want to make sure that someone who has access to namespace A can create buckets in one account, but not in the other user's account.
Well, that's a weird example because there's multi-tenancy happening at two different layers there. There's Kubernetes level multi-tenancy where Kubernetes is multiplexing a bunch of different users to their namespaces to a common set of resources. And then the driver itself may be sitting on top of another multi-tenant provider of storage.
There's a better
and
way
the
to...
tenancy mappings don't have to be one-to-one or even have any mapping at all.
Yeah, we don't need such a complex example. A simpler example.
Sid, you still there?
Can you hear me?
We're losing the audio. I can kind of hear you.
Hey, hello.
It might be on my end. I can hear you.
Okay. Oh, I was saying we can use a simpler example. You can have the example is if you have two different tenants that really shouldn't have access to each other, but they exist in the same namespace. They'll by default get access to each other. We really this namespace level access restriction is kind of useless. It's not really very usable.
Well, it's what Kubernetes has, right? In Kubernetes,
Kubernetes has this. Like this is an admission webhook admission request. It has all kinds of
Are
things.
you showing something on the screen?
I am.
Sorry,
Yeah.
I'm not looking at my screen. All right.
Okay.
Coming back to the screen. Okay.
So this is a webhook request and response for admission requests, and it has the namespace, and the resource and user info. This is what I'm most interested in.
Yeah. I mean, there's a veto point. You can plug into the API server and like veto object creation based on all kinds of arbitrary decisions. But I mean the Kubernetes model is if you have access to a namespace, you pretty much can do what you want in that namespace.
Yeah,
and that
bucket sharing is what we're talking about. That's not entirely true, right? If you have access to a namespace, you can do anything in the namespace. Is that true?
Well, I mean, in general, like in general, the way that you divvy up a cluster is you either give someone access to all of the namespaces if they're doing some sort of administrative function, or if they're just a user consuming resources, you put them in a namespace and that's their sandbox. But you normally don't go finer grain than that. I mean, and then that's why pods can only attach to PVCs that are in the same namespace, and config maps, and everything has to be in the same namespace, generally speaking, for a workload. And that's just how you, and so Alice puts all of her stuff in Alice's namespace, and Bob puts all of his stuff in Bob's namespace, and they don't mess with each other, and it's a workable model. And so that I kind of presume that here that you're doing the same thing with buckets, right? If I put a bucket in Alice, if Alice puts a bucket in Alice's namespace, all the pods in Alice's namespace can use that bucket, but
fine.
Bob's pods can't.
Right.
And that's by default that's your security model, right? It's limited to the namespace. But then we said, well, there's situations where you want Bob to be able to access Alice's bucket, and so what do you do? And then we get into the whole brownfield discussion of, well, we got to create another BR or another BAR, and so that Bob can see Alice's bucket, and you know, that's still TBD exactly what that looks like. But
even with Kubernetes, there's a service model where it plugs, you know, information about the service in the entire cluster. All namespaces get information. It's like a publishing model, right?
But you mean that the DNS system is based around namespaces? Kubernetes built-in DNS,
right? But even I mean that you get the environment variables for every service in your other namespaces, so you can access these for, you know, if you have sort of a service-to-service model where you want to access these different services from within the cluster. So the one thing that seems like similar in this model to me is this, where, you know, one namespace is creating this service, but then others are interested to consume it in some ways, right?
But it's not a service; it's a storage object that can be shared, but you might not want to share it, right? That's
object is stored as a
decision.
service, essentially, right? It's not, you're not really, you know, getting, you know, you're not managing storage by consuming it. You're just accessing like the service piece of it. And then if I already provisioned it, right, I did all the storage, you know, definitions of what to provision and where and whatever. And then perhaps I want to, you know, I want to give you the service, that service.
I disagree. So, I mean, the service exists outside of the cluster, right? Like the S3 bucket service is available to everybody, right? And so if Alice creates a bucket and fills it up with data, nothing stops Bob from also creating buckets. What Bob can't do is he can't get at the data in Alice's bucket, right? It's the data that Alice owns by virtue of the bucket being hers. And so if you know, the service for buckets is available to all of the namespaces. Anyone can go create a BR and out will pop a bucket, but it will be empty. It's if Bob wants Alice's bucket with Alice's data, then he needs some sort of handle to it, and then security becomes an issue. But the service is just anyone can get buckets if they want them. It's the data that has to be protected.
Right.
I mean, I refer to the service as, you know, providing a bucket service, in the sense that you get access to a specific bucket, just like I provided a service that provides whatever. Let's say I provision, you know, some Redis, right, and provides a service on my cluster, right, with Redis. Then I essentially give access, right, in some form, but needs to also exchange access keys then still, but then, or some tokens, and I give service to my to the cluster with my you know, namespace, right? And when I allocate a bucket, I think about it similarly, so that if I now want to share it, and I'm not saying that it's the default in buckets, but I think with brownfield, or with the case where we're saying sharing buckets, the model is similar to I want to provide access to others in the cluster, like I, you know, somehow provided access to a Redis service that I provisioned.
I don't know much about Redis, but like there's different ways of sharding those kinds of services, and you
Postgres, you know, take whatever data service you want, right?
We're going down on. Yeah. So, yeah.
A database and an object store are not that different, right? What I'm trying to say, it's a data service.
With the database, you could have a model where like each database is a separate object and each one is not shared. And so, yeah, anyone can go get an empty database. But if I want to get the database with the tables that have been filled up by some other user, then I need a handle to that specific database, which would be like, you know, a PVC or a BR or a database or whatever. You know, whatever.
No. So I would access it, but I would, if I'm a client, I would access it through, you know, some like your URL, like a service URL, and not. I'm not going to go directly to the PVC of that, right?
But the whole
That's
model here is like, it's the BAR that is what your pod links to, right? That when I create a pod that's consuming Cozy, all I need is the name of the BAR. All the other details are transparent to me, right? Or
no,
not
but
transparent.
BAR is something I create in my namespace, right?
Right,
Yeah,
right.
yeah.
Yeah.
But that is the hand. So in our model where we were talking about how to do brownfield, there was one potential design where you just create a BAR that points at someone else's B,
Mhm.
and
Right.
if it passes all the security rules, it binds and you're good
Yeah.
to go. You just create your pod. But it's those security rules where allowed namespaces came in, because there's no other way to
Right.
prevent someone who you don't trust from getting a hold of your bucket.
Not
So
anymore.
Right.
that's how I was viewing allowed namespaces. Is it is the one thing stopping Bob from creating a BAR that points to Alice's B and then reading all of her
Mhm.
objects out of her bucket if she doesn't
Right.
want him to.
Right.
So in Cozy, we are the one. So Cozy is responsible to provide the credentials to the workload, and this is why when we're talking about Redis or whatever data service we're talking about, it's the credentials are not part of the scheme, right? You don't have any specific way where you hand off credentials to another workload to access a service from it, like
Yeah,
the
in Redis
first
you're just
namespace, right?
in Redis you're just sharing the URL. That's all.
Right,
In
right,
many
but
cases,
typically you also need some credentials or tokens to make that happen. It's not usually it's somehow
it's
protected,
not.
and so
Yeah. Yeah.
Postgres, MySQL, all of them have some credentials access. So what Cozy is trying to do is also provide the credentials. This is why we need some mechanism to
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 the
say who gets the credentials, basically, right? It's
Right.
it's more about the
And,
credentials than the
and
bucket. The bucket exists.
that's the BAR, right? Every time you create a BAR, we call the driver, allow access, you get a B or BA object. And then when the
Right.
pod links to the BAR, it's going to go get those credentials in that BA object and shove them into the pod using our injection mechanism.
Mhm.
And now we need to just but I think unless I didn't follow up, but you said the discussion was whether to use allowed namespaces versus RBAC or any other mechanism to get that decision, right? That
Yeah,
was the
there's a
question.
fundamental problem with allowed namespaces. It's static, and also at the same time, you're really not restricting. I mean, like I could, like, how do you define allowed namespaces? Like, how do you define? How do I put
It's a
this? Like,
list.
when you create the bucket, like it's very hard to tell these are the namespaces that require access to my bucket. You can't.
Definitely hard, but think about. I mean, let's think about what other
Mhm.
things
Well,
exists in order to exchange,
Allow.
credentials, right?
Mhm. I wouldn't say exchange
Uh,
credentials, but more like allow credentials to be created for that other user.
right,
well,
provide credentials. It's
Mhm.
not it's not a common thing.
Mhm.
so if you have a BR in your namespace and a provisioner has bound that to a B, and then you come along and create a BAR, it's assumed that it should succeed. Or nothing should deny you access if you created the BR and you created the BAR in the same namespace, right? That's just supposed to work.
Mhm.
Um,
Mhm.
so the question is what
Prompt.
if the bucket pre-exists the Kubernetes cluster, right? Or there's already a bucket out there and you have to get it into the cluster somehow, right? We had talked that this is the brownfield use case that we've gone around in circles on.
Mhm.
The initial proposal was, well, someone who's able to directly create buckets
Mhm.
goes and manifests the bucket object with the appropriate details, um, and
Sets allowed namespaces.
what? Yeah. I mean, you would need to, but the idea is because this not being dynamically provisioned, it's a static provisioning object or static provisioning workflow because it already exists. You just have someone create the bucket first, and then you create the BAR and you bind to it, or you create the BR and it binds to the B, and then at that point you're sort of back on the normal workflow. Then you can create a BAR, the system will provision a credential, and you can go. But that only works for one namespace. The question is when the second namespace wants to access the very same pre-existing bucket, do you go create a whole new B that points to the same bucket? So now I have two identical B objects bound to different BRs and different namespaces, or do we allow multiple BRs and multiple namespaces to bind to the same bucket? So you only need one of them. And what we decided early on was like that creates big
Not the BR, you
problems.
mean the access, right? The BAR.
No.
To,
I'm just talking about buckets at this point, because the idea is once you have a BR in your namespace, it's assumed that creating a BAR that points to it will result in a credential getting created, right? There's no reason it shouldn't. Once you have, if you have a BR in your namespace that is bound, there's no reason that creating a BAR shouldn't succeed because it's your bucket in principle. But the problem is when you, Alice and Bob both want to share like a pre-existing bucket, if you have two different BRs in both of their namespaces and they try to bind to the same bucket, you have like Kubernetes API level object binding problems where you don't know, you can't really bind one object to two other objects and still get all of the semantics that we want in terms of creation and deletion and item potency and the way the controllers need to work. I mean, that's a whole other discussion. So we agreed very early on, no, it's one-to-one binding, one BR to one bucket. And if you need another BR, you're going to get another bucket. And our early on approach to sharing the bucket across namespaces was, well, if Alice and Bob really do want to point at the same bucket, you just need two copies of the bucket object. And we had been there for a while, and I think it was Jeff that started pointing out this creates problems with like if you want to allow mutation of the bucket, like who's allowed to do that? Because you have two copies of the bucket, you've got two sources of truth. If Alice tries to change one feature of the bucket and Bob doesn't, who wins?
What does the bucket represent to you as a Kubernetes entity?
It represents a handle.
What do you imagine that people
to the actual storage? So like, so in there is like is an ID, or it's going to be the protocol information, you know, a pointer to the driver that created it, so that you can disambiguate if you have multiple drivers, and then crucially the ID that the driver returned for that bucket, which in many cases will just be like the fully qualified bucket name, you know, so the driver knows which bucket you're talking about. Just enough.
But should it reflect information about the bucket itself? But like policies or, you know, whatever. There's more information or region, right? Whatever.
Yeah, we were talking about all the different details that you might want to be able to control or modify through Cozy, and we never really, I think, settled on anything for sure. But
but we expect Cozy to also sync it back, right? So if you have these two things, two Bs, right, refer to the same external entity, do you want them to be syncing back changes between each other, or like if there's immutable things there?
Yeah, the idea is typically with a Kubernetes object, it represents the desired state, right? So if you have some aspect of a bucket and then Alice changes it because she wants to modify it, like now the object is updated to the new state that you want it to be in, and some controller would go make that real. But the problem is Bob
status kind of feels so. Yeah, go on, Bob.
But I mean, this is a discussion that happened months ago at this point, I guess. But the issue came down to, like, for things like deletion, for things like mutation, if you have multiple copies of the bucket and one of them gets mutated and the other one doesn't, or one of them gets deleted and the other one doesn't, it's not clear what the controller is supposed to do in that case, because it needs a source of truth, and if there's conflicting sources of truth, you're screwed. So what we said is, okay, we don't want to be in a world where we have multiple buckets pointing at the same actual bucket, because then it becomes impossible for any Kubernetes controller to know what to do with when those objects change. So we said, okay.
But we also said it's inherent between different clusters, right? Sharing the same bucket.
Oh yeah, that gets even worse. I guess I'm trying to reprise the whole brownfield history and how we got to the point where we said, okay, the idea was we only need one bucket to refer to the actual bucket. And if it was created by some user creating a BR, it'll be bound to that bucket, but that's not essential, because you could just have a B and no BR because the admin created it because it was a pre-existing bucket. And then you could have a bunch of different namespaces all directly refer to that bucket from their BARs. And then they can share, and they'll each get their own credentials. They'll all be bound to the bucket. The bucket won't have a controlling BR, but that's okay because it was imported directly. And then the only problem in that world is, what if you don't want everyone in the cluster to be able to create a BAR that points to that B, because by default, it's, the expectation is if you know the name of the bucket and you create a BAR, it should bind and you should get a credential and then you can go access it. So
Right.
allowed namespaces was intended for, in that situation, preventing just anyone from getting access to a bucket. And the idea is at the time the admin imports it, that's his chance to sort of stamp a list of namespaces on it and make a decision about who can or can't access it.
But so one thing that comes up, if we're basically putting the effort on the admin to define this, right? We're a list of who can and who can't. It's not automated in any way. And then why won't we also tell the admin to be kind enough to create the BAs as well? And that's it, right? We just, if you set up the BA.
Yeah, right. So the idea is by default, an admin could do this, but like you would eventually want a controller that would automate this import process.
Right. So allowed namespace is sort of an automation to pre-create these BAs for these names, or maybe create on demand, right? But like it could be also pre-created as well.
Well, you can have multiple BARs for the same bucket in the same namespace, and that was a design decision we made early on, based on the assumption that just because you're in the same namespace doesn't mean you want every workload in that namespace to use the same credential to access the bucket. You might want one to have read-write access and another one to have read-only access, and so you need two credentials to affect that.
Okay.
So the idea was BAR creation
to
should
limit
be
just namespaces.
Well, I mean, it should be self-service, and initially the design was it always refers back to the BR that's in the same namespace, and that's your security mechanism, is you have to be in the same namespace. And then when we went to this brownfield case where you want to allow sharing, and we decided it was a bad idea to start cloning the bucket and having BRs in every namespace, then you end up with this weird security situation where you can't rely on the fact that there's another object in the same namespace that you can check to see if you're allowed to do what you're supposed to do. You need another handle. And so we embedded it directly in the bucket and said, well, the bucket knows who's allowed to talk to it. And of course you can change that, right? Like if Alice creates a bucket that's usable only by Alice, and then later she decides she wants to share it with Bob, she can get someone who has the appropriate modify access on bucket objects to go add Bob's namespace to her bucket. And then all of a sudden Bob can now create BARs pointing to that bucket. But that's a privileged operation to go modify the list of allowed namespaces.
Maybe if you have a BR, if you are the creator of the bucket, basically, then you could change it on the BR.
Yeah, we haven't really talked about how you might automate the changing of the allowed namespaces, but you need somewhere you need a control point where you can say you're not on the list. I'm denying this request. If you don't have,
how does this work with RBAC though? Does it RBAC? I know RBAC has named resource, but then what should, I mean, the user is creating this somewhere.
Yeah, the idea is ordinary users can only create namespaced objects, and the bucket is a non-namespaced object.
Right.
Therefore,
so you need a cluster role.
Yeah, you need some cluster role to be able to do this. So that's what separates people who are allowed to just create BRs and BARs from people who are allowed to create buckets and bucket accesses directly. But that's all the RBAC that we've really talked about, I think, is that there's this concept of an end user role and there's a concept of an administrator role. And the controllers basically need the administrator role to perform their function. They need to be able to see all the bucket requests and all the namespaces.
Go ahead. So I want to question something here. We're not really, when it comes to access, something seems off about the model that we have right now. And what I mean is, with data, when we say things like we want someone in this, one person in the system to only have read-only access, even in the same namespace, and another person in that same namespace to have, say, read-write access to the same bucket. Now, it doesn't really make sense, right? If you have unchecked access for everyone in the same namespace, then
it's not unchecked. It's checked to provide credentials. But once you're in the namespace, what we're saying is that if you create BARs, different ones for different pods in your namespace, you might have in your BAR different, like read only, right, or something like that. I don't know if there's more, but you know,
Not a, it's
some
not a
different
specific-
models of restrictions, right?
Yeah, so you're saying
But
only
then it's in the namespace users sort of world to control.
Yeah.
So
Yeah,
I
the,
see.
the user may not entirely trust the application he's running not to destroy his bucket. So he
Fair enough.
might decide to run the application in read-only mode,
Mhm.
whereas other applications he trusts more, and so he gives them write access to his bucket.
Fair enough. Yeah. Okay.
And it could just be a question of how buggy the application is, you know.
Yeah,
We're
it
talking
doesn't have
about
to be
developers here.
just incompetence. Okay, so the next question is, what if instead of using allowed namespaces, we started using, just much more fine-grained access control. So say, for instance, if the user that's creating a BAR belongs to a certain group, they can access the bucket regardless of which namespace they come from.
What do you mean by group? You mean the Kubernetes level group?
Mm-hmm.
So that means that when Bob creates his BAR and he uses the name of the bucket that Alice created,
Right.
that then the controller that's going to attempt to bind those things will first consult. Well, he
Yeah,
knows that
that's very easy to do thanks to admission controllers.
he knows that, or the
Yeah.
well, we're admission controllers control whether you can create the object or not. They don't control whether things can. I mean, the binding is after the object is created, you're mutating fields. That's what binding is.
So
Right.
I'm saying we reject that request if that user does not have permission to bind. So
But if he will have permission later?
so you're okay. So in that case, the binding is also an update operation. Then we could put an admission control on the binding logic. I don't think the problem is with the actual creation. In the sense, yeah, if they want
That's why I started with, the object, the BAR creation succeeds, but it hasn't bound yet. The
right.
controller that would normally bind it to the BA is first going to go look up the bucket
Mm-hmm.
and decide whether this is okay or not. And at that
Right.
point, how is it going to figure out the user or the group of the creator of the
Yeah,
BAR
that's what would be specified in the bucket class.
in the bucket class?
Yeah, and
We're talking about bucket access now.
no, it has to be in the
so
bucket. So
I
the
think
bucket class,
what you're saying is that the bucket will contain instead of allowed namespaces a list of groups, like allowed groups,
Allowed
let's say.
groups.
Same, right? So it's the same model, just that it's not
But
a direct namespace. It's you have to check the service account, or what will be the model for
right.
validating a user.
objects, I'm just confused because objects don't have groups. Like once the object is created, it forgets about who created it.
Right. That we can get over that very easily.
How?
Admission controller on the bucket access request that just takes the group, puts it into an annotation or something.
But then what if you change the annotation after you create it?
Well, that's their fault then. I mean,
we're talking about a security mechanism here. Like it has to be bulletproof.
fair enough.
But
I'm very wary of all of a sudden adding groups-based stuff in a Kubernetes API. Groups are used in RBAC, but not beyond that. If we start looking into the groups lists, etc., I don't really see any precedent in Kate's API.
Yeah, that's what I was going to say too. Is like I understand that group is a thing that the admission controller can see, but like this isn't. The admission controller's job is just to decide whether you can create the object or not. It doesn't get to decide whether you can bind the object or not, because that's all after the object is created. Then the bind controller comes to look at it, and it doesn't have any of the history of who created it. It just sees the object that was created and says, can it bind? And it needs to be able to figure out just from the existing objects whether it can do its job or not. And I think any concept of the user that created it or the group that created it is lost at the point that you're trying to do a bind.
Fair enough. This was kind of, I'm thinking it out loud as I go through this.
Yeah.
So
What didn't you like in allowed namespaces? I'm trying to also kind of
it's not a security
understand. Not sure if I
it
heard.
solves some problem that we've come up with, but it's not a security mechanism. You're not securing anything this way. You know,
It's an access control list, right? It's basically where you say what I allow. Who do I allow?
I totally grant that it's a crummy access mechanism, but I do think that it works. I think that, you know, if the list is a singleton list that says Alice and Bob tries to, you know, create a BAR, it's pretty obvious that you can deny that request. And then if
The
you
whole
want
may
Bob
be
to have
that
access, you add Bob's namespace to the list and then try again.
let's say so.
We're not, you know, say you are not allowed to create this namespace name, right? So if somebody's trying to, you know, just, you know, it sees like a list of allowed namespaces on some exist in the cluster, it's kind of a
Hello,
Yeah, we're losing you,
guy.
Nicholas.
oh, didn't you hear? Sorry,
That's guy.
I said, can you hear?
Yeah.
I said that it sounds like there's some you know, loophole here where, not loophole, but you can, you know, if you can see the list of the allowed namespaces of some bucket, you can then, you know, try to hack it by creating a namespace quickly, like saying if one of them doesn't exist in the cluster.
Namespace creation is privileged.
Yeah, right.
So yeah, the idea is if you're Bob and you're stuck in Bob's namespace, then you can't create new namespaces. And if you're not on the list, then there's not a lot you can do to gain access to a bucket. I admit that it's not the greatest access mechanism, but I do think that as it does what it's as advertised to do, which is allows some and denies others.
But there's something weird around it that you know, new
I
projects
totally
is something that
Let me
you
ask
typically
you.
want. It's like a service thing in clusters anyway.
Yeah, do we even need this? Like, do we even need to restrict access to buckets this way?
And there's not precedent really for doing a list of namespaces.
I agree with that too. There is not precedent for it. We're guys, we're at the top of the hour, and this is an awesome discussion that we should
continue on
continue.
Thursday.
But I don't want to lose the momentum we have because I feel like we're close to something. But yeah, I don't know what else we can do other than just postpone it.
Yeah, let's continue on Thursday. I have another meeting at 12 actually.
Okay.
So gotta get going.
Okay.